My pleasure to introduce our next speaker, Stan Buman. Stan and Agren continues to develop a fast, accurate, and easy-to-use software for planning structural practices. And Stan is going to show us and demonstrate some of those pieces of technology and software. Stan, are you with us?
Yes, I am.
All right, going to switch the presentation over to you, Stan, and put you in complete control. Are you ready?
Yes, I am ready.
Okay, here it comes.
Okay. Okay, so I am Stan Buman with Agren. I'm a Carroll, Iowa-based firm, and we do work around the nation, so we are not just located here in Iowa as far as the type of work that we do. What I want to talk to you today about is more on the conservation planning, actually getting conservation on the ground. And so I'm going to approach this from the standpoint of integrating technology into natural resource management. And I'm going to put in there with the caveat of, will it get conservation on the ground faster? As we do projects, as we come up with tools, that's what we focus on, is will it get conservation on the ground faster? So today there's a lot of demands being placed on agriculture. People are looking for clean water, and food production is huge. And at the same time, we're faced with a lot of agencies losing their planning staff, or at best maybe holding steady. Well, if you're losing planning staff and you continue to do business as usual, what you get is loss. You get less of the same. If you have less staff and you're doing business the same way, you know, we're going to have less done. And this is a time when landowners probably need more assistance. So what it really boils down to is, if we do business as usual, we have even longer wait times than what we're experiencing now, and we're still giving few options to landowners. So I'm going to talk about just a couple of tools that we have available. Let's start with our soil loss calculator. So soil loss calculator really is the Russell II version on steroids, you might say. So back when I used to work for the USDA Natural Resources Conservation Service, if we figured soil loss, the first thing we'd have to do is figure out, okay, what are all the different soil types, how many acres of each soil do we have, and what's our critical dominant soil. So in this case, our critical dominant soil would be the 822D2 Lamoni. Okay, so then we'd take that and we'd plug that into the Russell II. We'd figure an average percent row grade and an average, an average percent slope and an average length of slope, and would come out with a soil loss on this critical dominant soil of maybe 20 ton per acre. So what? So what does that even tell us? Well, I think what it tells us is very little. We actually took a soils map, and on the right is a map showing slope data based off of LIDAR. So now you can take a look at, let's say, just like this, this 138 C2 going in through here, and we can compare that over to here, and we have slopes ranging all over. We have some that's 4 to 6, some that's 6 to 8, some that's even 12 to 14, all within a C slope, which is 5 to 9% slope. So using the Russell II calculation in the old method, what it tells us, if somewhere we can find a slope length of 12% and 150 foot in length, our soil loss expectation would be 20 ton per acre. We'll contrast that to the soil loss calculator that we have now developed, and you can start looking at tons per acre gridded out like a yield map. So every 9 meters by 9 meters across this field, we can start showing soil loss to a landowner. So you can depict whether they have deposition, which is the black, or really high erosion, which is the red. So let's take that a step further and talk about options for landowners. Now, if they're in a conventional tillage system, say corn bean with tillage each year, you can show them where the high erosion is. Contrast that to adding in a few terraces over in the southern part of this field, and you can see it really doesn't do much for the upper end, which you would expect, and you can see what it does for the lower end. And then contrast that to the whole no-till situation. What's going on with no-till? And usually when I show this to landowners, they're like, wow. I mean, that's their impression all the time. They look at it and they are very visual. They're used to looking at yield maps. And the color coding really shows them what's going on in the field and where their hot spots are. So I'm going to talk to you a little bit now about planning structures. I think some of you are familiar with our LIDAR-based conservation planning tools, for planning ponds or wetlands or water and sediment control basins or even waterways. And what I'm going to do today is just talk about one of those and taking it even beyond just planning. So this is an example structure that I planned in about, say 10 minutes. I simply drew in my dam, drew in my watershed, drew in the longest path that water flows through the watershed, and then I just denoted what's crop, what's trees, what's roads, buildings, etc. And in about a 10-minute time frame, I can show a landowner what the permanent pool would look like, what the temporary pool would look like, and give them a very accurate cost estimate. So when a landowner walks in the door in about 10 minutes, you can provide them the information that they need. So, like I said, you can give them a very quick cost estimate. But let's take this a step forward and think about some other things that we can do with this. So I could plan this structure for a landowner, but what if we're working on a watershed project? Is this really the best location? Is it really giving us the best bang for the buck? So I'm going to talk briefly about precision conservation. And the way I'm going to define precision conservation is putting the right practice in the right place to achieve the biggest benefit for a conservation buck. And when I'm talking about conservation buck, that usually means the taxpayer dollar. So let's run through an example. And in this example, I'm going to say that my watershed goal is flood control. So pick whatever your impairment is or what you need to work on. And I will use an example of, like I said, flood control for this example. So we took a small watershed over east of Des Moines, and we figured out soil loss using our soil loss calculator so that we have an idea of what kind of protection we have in the watershed. From there, we just planned 20 structures. And, if you're planning structures about 10 minutes apiece, this is about a 3 to 4 hour process to plan 20 structures within the watershed. Okay, so we can plan them, but what does that mean? Well, let's take that another step further. So let's look at cost of ponds first. So each time we plan a pond, we get a table of maybe 200 to 300 different options, everything from the smallest pond we can put in to the largest pond. But for flood control, we really want to look at something that's going to give us a good permanent pool usually. But then the main thing is we're looking at bigger dams, smaller pipes, because we want to hold that water back and we want to be able to store it and release it slowly in case of a flood event. So we use dams with a pipe size of about 10 inches. So things that were important to us is the cost of the pond and the capacity of flood control. So what's the temporary pool? So first we took a look at the cost of each pond and we graphed that out showing how much each pond costs. And then we looked at the temporary pool. So you have your permanent pool where the pipe goes through the dam, but what we care about is everything from that permanent pool up to the emergency spillway, which is the temporary pool, and how many acre-feet of water can we store. So again, we graphed that out showing, how many acre-feet of temporary water there is in the pool. But let's take that even a step further. Let's marry those two, and let's look at the cost per acre-foot of temporary pool. So now we can start quantifying, of those structures that were placed, which ones will give us the best bang for the cost or for the taxpayer dollar. And so these are the top 8. I just randomly selected 8 of them, and how many dollars it would take for cost per acre foot to build the structure. So I think the thing this does now is, districts have always talked about, should we be providing different cost share to different site or different practices depending upon the benefit. And I think this now allows you the ability to be able to do that. So imagine being able to offer a higher cost share to the farmer who has site number 5 than, say, the one who has site number 11, because we're getting a better bang for our buck for what we want to achieve in the watershed. So anyway, here's the 8 all graphed out. A few other things then is, I selected this based on temporary pool, but if you're interested in storing water, then permanent pool becomes an important component. If you want to look at yearly sedimentation, you know, how much sediment are you reducing, if you want to look at phosphorus or nitrogen. You can sort these however you want and figure out the benefit based on what you are trying to achieve in your own watershed. So that's just a quick example of how you can use just the PondBuilder tool that we have to use for citing conservation practices and really get into that placing conservation practices in the right place. So the precision conservation component. I want to take this a step further. We hope that within a year we will have machine control loaded on our tools. So we think this is very realistic to where a landowner could walk into a field office in the morning. You could plan the pond with the farmer, load it onto a thumb drive, give it to a contractor who has blade control on his dozer, and he could start building it without ever needing to go to the field and flagging it. Realistic? Yeah, absolutely. The technology's already there. So that's the goal that we are working towards this next year, is trying to get our files to where they are machine control. A few other things. Our conservation planning tools are all web-based, and so there is no need to load it on everybody's computer. Any updates that we make, you automatically get the next time you log in, of course. And we have worked with USDA to make sure that our tools are hosted in a secure USDA FSMA compliant environment. And I can tell you more about what FSMA means, but it's sad to say I probably know more about FSMA than I ever wanted to. But our tools are set up now to be FSMA compliant, which means that federal employees will be able to use the tools and not worry about whether the information is secure or not. The other thing I'll point out is the tools are fast, accurate, and easy to use. It's the way we build them from the standpoint. Probably the real quick demo I can give you that is we had an older employee that when I first demoed the tools to him in a computer lab, he had his arms folded across his chest and just was not too excited. But afterwards, I asked him what he thought, and he said, well, I'm hoping I can retire in a few more years and not touch a computer. Well, that employee actually has retired now, but he was by far the biggest user of our tools across the state. He had a SoilCon help him check his email, but what he really liked about it was the tools were easy, and he could provide information to landowners that he never could. He could probably do the engineering for a pond in his sleep at night, but what he couldn't do is show him the pool size and give him a cost estimate in minutes. And so I think that testifies to how easy the tools are and how accurate they are, and they're just fast to use. So with that, I'm going to end, and I will take questions later. Thank you.
Dan, thanks so much. Ray Ledgerwood again with you, and we so appreciate getting to see this new technology. Very exciting. You may have covered, is this available nationwide, or are you reached out across all states?
Yeah, so right now we are in 3 states. In a matter of months we will be in 5 states, and we can easily gear up to other states. We do need good LiDAR data in order for the tools to run. That is a caveat.
Outstanding, Stan.